This is Grade 5 Math, Chapter 1.4, Rounding and Estimating. The objectives in this lesson are to round numbers to the nearest thousand, to locate numbers on a number line, to use rounding to estimate sums, differences, and products, and finally, to use related multiplication facts to estimate quotients. Let's begin. In our first example, we'll round numbers to the greater thousand. What is 6,451 rounded to the nearest thousand? We'll use a number line to help us the very first time we try this. So we're going to place 6,451 on our number line. So here we have 6,000 to begin with. The next interval is 6,100. 6,200 is next. Then 6,300 and 6,400. So we know our number is going to be about roughly here will be our, 6,451. Okay. So the question is, if we're going to round to the nearest thousands, and the thousands place would be the 6,000 or the 7,000, will we round 6,451 to 6,000 or 7,000? Well, which is it closest to? If we look at our number line, we can see that the 6,451 is to the left of 6,500, which is our halfway mark. Therefore, our number is closer to 6,000, and our answer will be 6,000. Let's try another example using the number line to help us round to the nearest thousands. Our number is 8,776. We can see on our number line that this number lies between 8,000 and 9,000. The number is greater than 8,500, which is our halfway mark. It is to the right of that number. That's how we know it's larger. So 8,776 is closer to or nearer to 9,000, and thus our rounded answer is 9,000. How do we round, however, if our number is exactly halfway between two thousands points? In this example, let's take a look at 9,500. It's exactly halfway between 9,000 and 10,000, so what do? Well, whenever your number reaches the halfway point, you round up. Therefore, our answer is 10,000. Just as a quick review, if you're rounding a number and the digit is between 0 and 4, you round down. If the digit is between 5 and 9, you always round up. Just remember that simple rule. Whenever you're rounding, it really helps make the job easier. Now try this idea on your own. Please round each of these numbers to the nearest thousand. Record your answer in your homework notebook. Now let's use an example that uses a larger number. We're going to round 85,210 to the nearest thousands. First, let's draw a number line to help us. First, we create our number line with 85,000 at one end and 86,000 at the other. The exact center of our line will be 85,500. That's halfway between. And then let's make our interval marks for 85,100, 85,200, and over here 85,600, 700, 800, and 900 before we get to 86,000. Now we're going to place 85,210 on our number line. We're just going to estimate that it's going to go about right here. That'll be our 85,210. So looking at our number line, we can see that 85,210 is closer to 85,000, and therefore our answer is 85,000. 85,210 rounded to the nearest thousand is 85,000. Let's have you try a few more of these problems on your own. Please record these in your homework notebook. So the first asks you to use a number line to mark the position of the numbers. Just make your best estimate as to where it would go. And then round each number 125,231 and 125,780 to the nearest thousands. Numbers 6 through 13, simply round each number to the nearest thousand. Press pause and move on when you are ready. The next type of problem we'll see are fun little logic problems. They go like this. Rounding to the nearest thousand, what is the least number that rounds to? So, we're going to start with the number 4,000. This question first asks us to think about what numbers will round up to 4,000, because it's asking us what's the least or the smallest number that will round to 4,000. Well, thinking logically, we know that this number is going to have to start with 3. It'll be less than 4,000, right? So it must be 3,000 something, something, something. Okay, so how can we find the smallest number that will round to 4,000? Well, you could use a number line if you like, but I prefer to just think it out and logic it out in my own brain. So if the number is going to round up to 4,000, I know that there has to be a 5 in this position, right? Because the only numbers that would round up, that would force the 3 to change into a 4, would be 5, 6, 7, 8, or 9. Well, we want the smallest one, so we're going to go with 5. We'll get rid of these guys, okay? Now, if I want this number to stay the smallest it can be, I'm just going to leave it at 500. Because any number that is greater than 500 is going to force that 3 to change into the 4,000 and thus cause our number to round up. So our answer in this example is 3,500. Let's try another. If we take the number 80,000 and we want to find the least number, the smallest number that could round to 80,000, the nearest thousands, what would that number be? All right, well, we want to force this something to turn into 80. And the closest number that would be less than 80 would be 79, right? So the smallest number that we could once again have would be 79,500. Because we need a 5, at least a 5 in this spot, to force that 9 to round up, turning it into a 10, which makes this 80 instead of 79. Once again, we don't have to add anything here in the tens or ones spot because 500 is the smallest number that could force the 79 to round up to 80. Let's try a couple of these on your own. These are fun. In your notebook, please record the least number that will round to 9,000 and the least number that will round to 60,000. Have fun! Now let's try this same idea but working in the opposite direction. So this time, rounding to the nearest thousand, what is the greatest number that will round to 7,000? All right, so now we're looking for a number that's bigger than 7,000. But do we want to go to 8,000? What do you think? No, we probably don't. We want to go greater than 7,000 if we think about a number line here. But we don't necessarily want to go all the way to 8,000 because that will be far too big. And remember, we're looking for the greatest number that will still round down. So it has to be less than 7,500 if it's going to round down. Okay, so we're going to start with 7,000 here. Now, logically, our number can't be 7,500. We know that any number that's greater than 5 is going to round up. So our number that belongs here will either be a 4, 3, 2, 1, or 0. We want the biggest possible number, so we're going to stick with 4. 7,400. Once again, we want the largest possible number that can round to 7,000, rounding down. So next to the 4, we're going to put a 9 and a 9. 7,499 is the biggest number. It is as close as we can get to 7,500, but it's still going to round down to 7,000. So our answer in this case has to be 7,499. Let's try another. Our next number is 50,000. Rounding to the nearest thousand, what is the greatest or largest number that will round to 50,000? Okay, so once again, we know we need to be bigger than 50,000. Our quantity has to have a value higher than 50,000. So if we're rounding to the nearest thousands, we know our 50 is going to stay as is. We need to change the hundredths, tenths, and ones place, not the thousands or the 10,000s place. So if we're going to round down, we know our number once again has to be 4, 3, 2, 1, or 0. And we want the largest possible number, so we're going to eliminate 3, 2, 1, and 0. We want 4. It's our biggest possible number. And just like in the last problem, we're going to put 99 here. That's our largest possible value. That gets as close to 50,500 as possible without pushing us over the halfway mark and forcing us to round up. So our answer, once again, is 50,499. Okay, try these two on your own. Use rounding to the nearest thousand. What's the greatest number that's going to round to 2,000 and 90,000? Please record these in your notebook. We're going to apply our estimation skills to rounding sums and differences. This will help make some large digit addition and subtraction problems quick and easy. It won't give you an exact answer, but it'll get you in the right ballpark. The two digits we'll be working with are 6,521 and 5,079. We're going to round each to the nearest thousand. 6,521 rounds to 7,000. And 5,079 rounds to 5,000. Now, using the rounded digits, we're going to estimate the sum or the difference between these two quantities. Let's start with the sum. If we're estimating the sum of 6,521 and 5,079, we're simply going to replace these digits with the numbers we've rounded to. And then we're going to add them together. 7 plus 5 equals 12. So our answer is 12,000. Now let's try finding the difference using estimation. Let's estimate to solve 6,521 minus 5,079. Once again, we'll simply replace each number with the estimated amount, or the rounded amount, excuse me. And then we solve. We know that 7 minus 5 equals 2. So our difference is 2,000. Whoop, whoop, warning, stop. Some students are tempted to actually add the digits and then round the answer. While in this case, yes, you get the same answer, 12,000, that is not the proper set of procedures for this type of problem. Round first, then add, don't add, then round. Same goes for subtraction. You may be tempted to solve the problem as written and then round to get your answer. Do you see the problem in this case? It actually gives you a different answer. In this case, you get an answer of 1,000. Instead, if you had used the estimates first, your answer would have been 2,000. In this case, if you do the process in the wrong order, you will get an incorrect answer. So make sure you round first, then complete the process. Don't complete the addition or subtraction process and then round. Okay? Warning over. And here are your last 4 guided practice problems for this video lesson. In each of these problems, please round each number to the nearest thousand, then estimate either the sum or the difference. Record these in your homework notebook. In tomorrow's video lesson, we'll begin to explore front-end estimation with adjustment. Have a great night, and I'll see you in class tomorrow.